And also, before we end the period, I will give back your Unit 1 tests now that we voted. Okay, here we go. Let's start this as a group. First, I warned you guys yesterday, don't overlook that I'm giving you that those are lines, and in this case, those lines intersect. That's a little hint to you guys what might be coming. Either vertical angles might be coming or supplementary angles. One of the two, probably. Next question I have for you. How many angles are getting bisected? How many angles are getting bisected? Just read the givens. How many angles am I bisecting? One angle ADB. And I asked that because I can automatically I know usually bisects, we do halves of equal quantities. But how many angles do you need to bisect? Two, right? Quantities. We're only bisecting one quantity here. So this is not a halves of equal quantities proof. All right, it is not. So what I need to do instead is use the other definition of bisects. So yes, it cuts an angle in half, but it also cuts it into two equal angles. Where are they here then? Because that's what I want to use in my proof. Where are these two equal angles up here? And I'm not going to do numbers. You either know it or we don't by this point. Kira, where's my equal angles?
AED and BED.
AED?
Yeah.
Down here?
Yeah, can you say it?
Oh,
wait, ADE.
I was going to say ADB is getting bisected, so it should be angle ADE and BDE. Everyone's got those two? So angle ADE is congruent to angle BDC, or BDE, excuse me. And what's that reason going to be? Not on your sheet. Not everything is on your sheet. Gage?
Definition of a bisector.
Yep. Remember that. Please know that going into Monday. Not every reason is on your sheet, and here's one of them. Definition of a bisector. All right, so it looks like you guys got me ADE going. You got me angle ADE. I look at the proof statement. I need to prove ADE and FDC. So maybe now you want to introduce FDC into the proof. So is there anything you can tell me about angle FDC in that diagram? Because I probably want to mention that. Tess, what do you say?
FDC is congruent to EDB.
To which one? EDB. Yeah, hey, that's why I gave you the intersecting lines. Those intersecting lines form these vertical angles right there. They form those. Awesome. Awesome. So now I could say angle FDC. Bless you. Angle FDC is congruent to angle BDE. And what's your reason here? Violet. Vertical angles are congruent. Remember, you do not need to tell me that they're vertical. Perfect. Now we got FDC involved. Look at your work, please. Look at your work. Look at what we just did in steps 2 and 3 so we can finish this. We said ADE is congruent to BDE and also FDC is congruent to BDE. Want to put those two steps together and come out with what two angles being congruent? Zach?
ADE is congruent to FDC.
And what property are we using for that one? Substitution. So that's how this one ended. Substitution. And that's where we need to be. Anything you'd like to ask on that one? Okay, here's the way the rest of class is going to go today. You and your group, the entire group, you're going to talk to each other, even though if you're not a big talker, we got to be today. You are going to do number 2 right now. Once all of you have it completed and in agreement, you'll call me over and I will check it. If it's good, I'll allow you to go to the next proof. If it's not, we got to fix it. If you are stumped, call me over, please. But nobody moves on until the entire group has it completed and in agreement to it. So please go ahead and get going.